A very good morning. Today's class will be on electronic apex locator. So the contents includes introduction, importance of working length, various methods to measure root canal length, methods for determining working length, why electronic apex locator, fundamentals of operation of electronic apex locator, evolution of electronic apex locators, and problems related to electronic apex locator, and conclusion. So before starting with the introduction of apex locator, we have to know what is the main goal of a root canal treatment. The main goal or objective of root canal treatment is to control infection through complete debridement, disinfection, and filling of the root canal. So to achieve this goal, the root canal treatment should be confined only within the root canal system. And the canal terminants must be detected accurately. So this includes the precise control of working length during the process. There are several techniques available for working length determination. Today, we're going to discuss about electronic apex locators. So methods for determining working length are radiographic methods, electronic apex locator, tactile sense, paper points, average tooth length, and microscopic magnification. So before start with the electronic apex locator, we have to know the morphology of the root canal terminals. In 1955, Cutler concluded that the root canal had two main sections. So section 1 has larger conical section in the coronal region consisting of dentin. And section 2 has shorter funnel-shaped section in the apical portion consisting of cementa. So in this picture, you can see major apical foramen and the minor foramen. A represents major apical foramen and B represents minor apical foramen. The shape of this apical portion is an inverted cone with the base being located at the major apical foramen. The apex of the cone located at the minor foramen. This structure coincides with the apical constriction regarded as being or at near the cemento-dentinal junction as per Cutler. This structure produces an hourglass shape. So, which is the end point which is the end point or the terminal point where the obturation should terminate? So there are three major structures. One is called cemento-dentinal junction, apical constriction, and minor foramen. Cemento-dentinal junction is a structure where the pulp tissue is converted into periradicular tissue or PDL. So it is an histological section, and this is inappropriate in the clinical situation. The another structure is an apical constriction. It's a topographic structure which is not constant according to the Dummer et al. In 1984, and it is not ideal in clinical practice. So the ideal structure where the obturation should terminate is the minor foramen. In clinical practice, minor foramen is the more consistent anatomical feature. It is the narrowest portion of the canal system. It's a preferred landmark for apical endpoint for root canal treatment. So why electronic apex locator? There are various techniques as we discussed in the earliest slides. So to determine the working length, most commonly used is radiographic methods. But the main disadvantages of radiographic methods are distortion of the radiographs, which leads to under or over preparation of the root canals. So this might lead on impact on the position of the root canal filling materials. The minor apical foramen and apical constriction is 0.5 to 1 mm short of the radiographic apex. So there will be wide variations in the relationship of these landmarks. Next, the accuracy of radiographic methods usually depends upon the radiographic technique. There are two types of technique. One is bisecting angle technique and paralleling technique, in which the bisecting angle technique was less accurate than the paralleling technique. And sometimes it requires higher density radiographs. So there is a need to reduce exposure of ionization radiation so that we're gonna use electronic apex locator for determining working length. Next are the fundamentals or operations of electronic apex locator. As we know, the human body is a good conductor of electricity. That means we might allow the passage of current through our body. So, according to electrical principle, our body has atom, electrical charge, flow of electrons, and conductivity of ions. So this picture represents the basic atom model. You can see in the center the nucleus, which has protons and neutrons, and it has a revolving electrons. So the electrons, which is closer to the nucleus, have strong attraction towards the nucleus, and which is farther from the nucleus, which have weaker attraction. An electron which gains an electron is negative ion, and which loses an electron achieves a positive ion. The conductivity of a fluid or a solution depends upon the total charge of ion and size of the ion. That is, larger ions offer greater resistance to motion. So principles of electronic apex locator. You all people know what is Ohm's law. V equal to IR, where V stands for voltage and I stands for current. The R stands for resistance. So the same principle is applied in the electronic apex locator. So based on this principle, it was concluded that the tooth atom has some electric potential towards the flow of current. That means the tooth has both conducting electrons and resistance towards the electrical current. So as we know, the parts of the tooth are enamel, dentin, pulp, cementum, and PDL. In this enamel and dentin are least conductors of electricity, whereas pulp and periodontal ligaments are, compared to enamel dentin, they are more conductive to the electricity. So whenever we place both the electrodes, positive and then negative electrodes, when it is attached to them, when we apply some potential difference, there will be a flow of currents. There are two types of current. One is called direct current, and the second one is called alternating current. So direct current has a single flow of electric charges, whereas the alternating current has an high crest and trough. It has an amplitude. So this is a typical circuit of electronic determination of working length, in which there will be a file clip which holds the file, and then lip clip, and which is attached to the electronic apex locator. Whenever there is a change in the resistance or the flow of current, it is measured in the monitor, which is shown in the electronic apex locator. Next thing is an evolution of electronic apex locator. So There are 6 generations of electronic apex locator, and generations are only for marketing purposes. So generations means there is some modifications, means the disadvantages of one generations are the advantages of the next generations. So first generation apex locator used direct current, and it is only used in the animal models. And then the second generation, they measure the resistance to alternating current. The types are a resistance type, impedance type, and frequency type. So examples of resistance type are root canal meter, Sono Explorer, Apex Finder, and impedance type are Endocator. Frequency type, there are two types. One is difference type, and the another thing is ratio type. In difference type, the examples are neo sono, and ratio types, there are two types, two frequencies. One is two frequencies, another thing is 5 frequencies. In the ratio type, we using two frequencies, root ZX manufactured by J Morita, are the most commonly used apex locator. The most commonly used apex locator, which shows 96% of accuracy in determination of working load. So first generations are resistant based apex locator. The first in 1988 cluster determined the root canal length by using electrical conductance. In 1942, Suzuki electrical resistance between the PDL and the oral mucosa in dogs obtained in constant value, that is 6 kilowatts. And this is the principle behind the apex locator. In this picture, you can see a file and a lip clip. So as the file reaches the apical foramen, that the length of the resistive material, that means the resistance towards the current, getting decreased since the pulp tissue, the distance between the conducting medium and the apical foramen decreases. So, so far, so the first generation apex locator, the advantages are easy to operate. It uses K-type files, digital readout, detects perforation, built-in pulp tester. Disadvantages, it requires a dry environment. File cannot contact the metal restoration. There should be no caries or defective restoration. It requires calibration for each canal. It requires liquid with a good contact. Patient often experience sensitivity. That is, and the most disadvantage are contraindicated in patients with pacemaker. Next, the second generation apex locator are impedance based. So in 1971, Inno introduced the impedance type of apex locator. In 1979, Deva utilized high frequency current, and in 1983, Yoshiyama used voltage gradient methods to determine the working length. So principle began the impedance based apex locator. There are two conductive materials parallel to each other. One is the file, and another thing is the PDL. And the insulating medium which separates the two conducting medium are dentin. So the tooth model acts as a capacitor. So that in the second generation, not only the resistance, they're gonna measure the impedance against the flow of electrical charges. So it measures the opposition to the flow of alternating current or impedance, and as a single frequency. Impedance consists of comprised of both resistance and capacitance. The property measures the distance in different canal condition by using different frequencies. So these are the examples of second generation apex locators. So advantages of impedance based, it can operate in fluid environment, and it has an analog meter, no patient sensitivity, operates with RC help. Disadvantages are, again, it requires calibration for each canal, and it requires coated probes. cannot use files, and it is difficult to operate. Next are the third generation emitters. It is similar to second generation except that they use multiple frequencies. It measures the impedance difference between two frequencies or the ratio of two electrical impedances. Calculating the difference between the two direct potential picked up by the filters when 1 kilohertz rectilinear wave is applied to the canal. Examples are apexic or index, root ZX. So combined accuracy of 90% to within 0.5 mm of the apical foramen or CBJ, depending on the reference point. 100% accuracy if 1 mm is accepted. So Kobayashi and Suda showed that the ratio of different frequency have definite values and did not change with different electrolytes in the chemical. So ratio in this, the ratio methods use two electric currents with different sine wave frequency will have measurable impedances that can be measured and compared as a ratio regardless of the type of electrolyte in the kettle. So capacitance increases significantly at the apical constriction. The quotient of the impedances reduces rapidly as the apical constriction is reached. This is the tri-auto ZX. It has integrated AND base with the apex locator, similar to root ZX. So advantages of third generation electronic apex locators are easy to operate, operates in the fluid environment, uses K-type files, analog readout, operates with RC prep, and low voltage electrical output. Disadvantages: must calibrate each canal, sensitivity to canal fluid level, needs fully charged battery. Next is the fourth generation electronic apex locator. And this unit uses two separate frequencies, 400 Hz and 8 kHz, similar to the third generation apex locator. Combination of using only one frequency at a time. Measurements on the root mean square values. The signal increases the measurement accuracy and the reliability of the device. Examples are apex locator Bingo 1020. It does not process the impedance information as a mathematical logarithm. Instead, takes the resistance and capacitance measures separately and compares them with the database to determine the distance to the apex of the root canal. Fifth generation apex locator was developed in 2003. It measures the capacitance and the resistance to the circuit separately at different positions to diagnose the position of the file. Disadvantages are difficulties in right canal. Accuracy varies with pulpal and periapical conditions. Sixth generation electronic apex locators are called adaptive apex locator. Continuously defines the humidity of the canal and immediately adapts to the dry or wet canals. Can be used in both dry, wet canals with blood or exudates, canal with pulp not extubated. So problems associated with the use of apex locators are: first thing is presence of irrigants might influence the conductivity of the electrical cutout. Next is the canal shape. A significant clinical step to a significant clinical step to overcome these disadvantages are the pre-flaring of the root canal increases its accuracy. Size of the apical foramen. Cardiac pacemakers. All the apex locators can be used except Bingo 1020. Advantages are detection of root perforation. Let us best accuracy in primary teeth. Conclusion. No individual technique is truly satisfactory in determining endodontic working length. The cemento-dentinal junction is a practical and anatomic termination point for the preparation and obturation of the root canal, and this cannot be determined radiographically. Modern electronic apex locators can determine this position with accuracy of greater than 90%, but still have some limitations. Knowledge of apical anatomy, prudent use of radiographs, and correct use of electronic apex locator will assist practitioners to achieve predictable results. So these are my references. Video